Morning, class. This video is going to cover C++ static members and member-wise assignment. We'll look at member-wise assignment as the ability to assign one object to another using the assignment operator. We can do that with objects. However, there are a few ground rules to cover with those, so we'll cover those. But then we'll mainly look at today static members, how we can have a static private member variable that is actually shared among all objects that have been instantiated of a class. Pretty cool stuff. All right, so let's start with static members to start. So when we talk about a static member, we're talking about a member that is persistent. You know, this is like having a static variable in one of our everyday functions. Normally, when we have a local variable inside a function, the scope of that variable is the function itself. And when the function ends, any local variables that have been created, those are destroyed. But if we put static in front of it, they're not destroyed. They are carried forward to the next function call. Matter of fact, the data stays resident in memory until the program ends. So it changes up the behavior quite significantly. And this gives us the ability to leverage this behavior and keep track, say, of the grand total of something or the number, the counting number of something. We can do this easily since that data is not destroyed between function calls. Well, we can do the same thing in a C++ class. If we had a private member variable, and let's say we wanted to have a variable that is going to count the number of goats that we create. You know, anytime we create a goat object, let's keep a running total of how many objects are created. So that sort of running total concept would lend itself right away to a static member variable. So the way we do that normally, we would just have an integer here called count. And that would be a private member variable, and we would just use it to count whatever we needed to count and return and whatnot. But to make it a static member variable, we just add the word static in front. This gives us a new capability now. It means that if we have this goat object here, I'll call it G1, and then we've got goat2 here, and then we've got goat3. It's going to be interesting because all three of them will share access to this count. So if any of those objects updates count, well, then it's updated for all of the objects. So let's put this in action now. We've got up in our class declaration here, the static variable. Then what this would need then is, of course, some code to manipulate it. And what we would do is in our, since we want to keep track of the number of instances that have been created, well then let's go to the code that actually creates our instances and put in some code to increment this variable. Now there's only two places where our code will create a variable, create an object. And that's in our two constructors, either the default or the parameter constructor. So we would go to both of those and just simply increment that count. So like inside goat, the default constructor, of course, we'd have a lot of other code here that is initializing the rest of the private member variables to dummy values. And deep in here, then we would just simply increment count. So when a goat object is created using that default constructor, it's going to increment that count from whatever we initialize it. We'll get to that in a second. It's just going to increment it. And now we have captured the fact that we've created one more object. We would do the same thing in a parameter constructor. And here's all the parameters, of course. Here's all of our code that initializes the data. And then we would put count in here also, count plus plus. And that's almost all we need to do, except you've probably already seen here a problem. Where do we initialize the count? Do we initialize that count inside one of the objects? Do we initialize it in main? What do we do here for this? Now, there is a special trick that we have to follow. This is part of the C++ convention for this. And that is that we would initialize this code outside of the class. So above main here, somewhere above main, that's where we will just simply initialize it. Now, normally we would just say something like count equals 0. But for us, we have to do a few more coding syntax things here to tie this properly, first of all, to the class, and second of all, to the static member that we're going to use as this grand counter. So what we do is we'll first declare it. We will declare it outside the class. Just like that. So we wouldn't do this here, but instead we substitute that more commonly used initializer to again point to which class we're talking about, and then we use the scope resolution operator, and then that points us to which private member variable we're talking about, and then that lets us both declare it and then initialize it to 0. So in our code from this point on, then anytime we created any kind of a goat, it is going to increment that private member variable. Pretty cool, huh? Now, let me shift to some code to demo this, and you'll see that this code is also up in your Eclipse in the sample code part. So let's share that now. Okay, here is some code to look at. Again, this is posted in Canvas. And we're back to our goats. This time we want to create that static counter that's going to keep track of the number of goats that we've created. So here is that static member. Normally we would just say int goat. In this case, we're going to make it static. We'll put the C++ reserved keyword static in front of it, and that keeps it persistent, and it gives us the behavior that this goat count is going to be shared amongst all goat objects. So we do that in our private member declaration area. We can do a quick get count getter. And it's so simple that we would use an inline function for it. We're just simply going to return the goat count. And then later in our code, right before our main function, there's where we initialize the goat count. Now the format of that looks a little weird because it looks like we're sort of redeclaring a second goat. But the way we do that is we declare it outside the class, initialize it outside the class, and the fact that we have used the goat class and the scope resolution operator to zero in on the goat count variable, that's what glues all of this together. And that's all the coding that we have to do, because when we create our goats here in lines 69 to 71, it's going to automatically create that counter and then automatically update that counter, incrementing it every time we create an object. Now then down here is where we can actually retrieve the goat count. And it doesn't matter which goat you actually get the count from because it's all the same. If we put in goat2 here, dot get count, or goat3 dot get count, it doesn't matter because they're all sharing the same variable, and we'd get the exact same results. So here we then, let's run this. And when we do run it, we see that this output at the bottom says, okay, yep, we created 4 goat objects, and it looks to me exactly like we did. So that is using static members. You can also use static functions, but it's much more common to use static members. Please read that little segment in the book for more information on abstracting this up one more level to the function level. But we're going to just stick with the static members in this course. Now, I mentioned also at the beginning of this video that we'll briefly discuss member-wise assignment, and that's what this code is right here. Member-wise assignment is where we just simply use the equality operator to assign one object to another. And we can do that with objects. We can use the assignment operator to just simply assign one previously declared object to another previously declared object. It's going to have the effect of a copy. Now here in line 74, there's where we create the extra goat. In 75, I'm going to assign whatever goat1 is just through the assignment operator to goat4. And then we'll of course output goat4, and you saw that there in the output in the console. So that's member-wise assignment, pretty straightforward. I mention it here just to get us thinking, because we have to change this member-wise assignment when we're dealing with a couple of things. First, if we have dynamic memory anywhere in our program, this process, member-wise assignment, is going to fault. It's not going to work, and I'll discuss that in one of the next videos. The other thing that this doesn't support is if we tried to create a goat with this very common convention here, where we create a new instance of a goat based on the template or the values of another goat. And this is a very common coding convention. And we're all kind of used to creating things like this. But member-wise assignment doesn't support this. We would have to do something else. So the something else that we'll do is going to be creating a copy constructor, and we'll deal with that in one of the upcoming videos. Okay, hope this helped, and this will definitely help with your Lab 5.1, and good luck.